All right, apologize in advance for the slate work here and the paintbrush. So we're going to try to make this work. I'm going to start with an example problem that's not on any of your worksheets, and I'll show you how to do this problem, and then it'll get you ready for 511. So, starting off, we have an example problem. It's tan x is equal to 1/2, oops, I have to fix that up, brushes, there we go, it's equal to 1/2, tan x equal to 1/2 over cosine x. Okay, solve for x. And we'll talk about solve for x in a moment. All right, so basically the problem sets up is I'm going to go ahead and move the cosine over because I can't solve as long as cosine's on the bottom. So I'm going to go tan x. Wow, this is terrible. Good luck. Cosine x equals 1/2. That'd be good algebra. Now, I don't know how to turn tan x cosine x. I can't solve that for 1/2. So I'm going to keep solving, simplifying, right? So the next simplification step would be sine x over cosine x times cosine x equals 1/2, right? Cosine x is canceled out, and I get where sine x is equal to 1/2. Now, knowing what you know about trig right now, if I say solve for x, the answer would have to be what? It'd have to be where the sine curve gives me 1/2. And so if I think about that for a moment, I would get, well, x is equal to 30 degrees. And then I'd start thinking a little harder and remember that, well, it repeats every 360, right? So I'm going to have to add in a plus 360 degrees n. Is that all of them, though? Remember, sine is positive in the second quadrant. So since it's positive in the second quadrant, it's also true, if I think about second quadrant, go over here and go, here's second quadrant. 30 degrees would be the reference angle, so this is 30 degrees. So it'd have to be 150 degrees, right? And so that would be equal to 150 degrees plus 360 degrees n, and that is the answer to the question. All right? And that would be a situation where I ask you to solve, this over here, solve for x. Now, mathematicians are lazy like everybody else, so therefore when we look at this, we say x equals 30 degrees is 360 degrees n, 150 degrees plus 360 degrees n. That's a lot of writing. Oh, I forgot my where n is equal to. Where n is equal to ... -1, 0, 1, 2, ... So again, starting out, it would be tangent x cosine x, it'd be tangent x equals 1/2 over cosine x, which would be over here, right? And then I would go, all right, well, in order to solve this, and you get cosine x at the bottom, so I multiply both sides by cosine x. Now I can do that because it's not a verification anymore. This is an equal sign, so I'm allowed to do that. And I get tan x cosine x equals 1/2, right? Now, I look at that and go, okay, wait a second. But then I got sine. Then I can't solve that, right? So then I start using the simplification rules. Do good algebra, or I did good algebra. I have nothing left. Then I start thinking about, wait a second, I can actually change tangent into sine x over cosine x. Cancel out my cosine x, I get sine x equals 1/2. Where does sine x, what values of x give me 1/2? That would be at 30 degrees and at 150 degrees, plus 360 degrees n, plus 360 degrees n, where n is equal to -1, 0, 1, 2, ... And as I was saying before, mathematicians are lazy like everybody else. So therefore, what they want to do is we want to figure out ways so we'd have to write all of these answers. Okay? So there's a simple way to do it. One of them is to say, I only want answers. So this would be different instructions than these instructions over here, right? What if I ask you to solve for x being greater than 0 degrees but less than 360 degrees? Okay? Well, if I did that, the only two answers from here that would work would be x is equal to 30 degrees and 150 degrees, right? And so that would be my two solutions. What if I was being really sick and angry and I gave you that it was solve for 0 is less than x, which is less than 2 pi, right? Then you'd have to convert those to radians, which would be pi over 6 and 5 pi over 6. Again, you could do that by brute force, by doing the conversion. Remember 30 degrees, where 360 degrees is equal to 2 pi, and then solve it that way. That would give you the pi over 6 version. So that's two more ways in which I can ask you to write the answer. There are two other ways you could do it. One of them says solve for principal. Well, that says principal values. Good luck reading that. And when I want to solve for principal values, I look at it and go, okay, so how do I solve for principal values? What does principal values mean? Principal values is a way to reduce it down to one solution, because when I use trig functions, I get 30 degrees and 150 degrees because it's always two quadrants positive. No matter what, if it was a tangent function, it would be first and third quadrants positive. Okay? If I asked you to do a negative tangent, it would be the second and fourth quadrants that are positive. So there's always two answers. So solve for principal values, it gives us one answer. This was initially designed specifically so calculators could do the math, because calculators don't like two answers. And so in order to solve for principal values, we have to have a situation where no matter what I ask you, it's going to be solvable, whether I give you a positive thing to solve for or a negative thing to solve for. So I need to give you a positive quadrant and a negative quadrant for each of these. So the way it's done is this. Sine and tan, When I ask you to solve a sine or tan equation, you're going to solve between 90 degrees and negative 90 degrees. In other words, you're going to solve this half of it. Okay? So for the previous problem, 30 degrees is between negative 90 and positive 90 degrees. So the only answer I would get is 30 degrees. Now the problem is that sine and tangent, this works well for, because sine and tangent are both positive in this quadrant and negative in this quadrant, right? And in fact, this is what your calculator does. If you were to go arc tangent of negative 1/2, you would get negative 30 degrees, and that's what your calculator would tell you is the principal value. That's why your calculator does what it does. But for cosine, we've got a problem, because cosine is not negative down here, it's positive. All sad tigers cry. So cosine's negative down here. If cosine's negative down here, then we've got a problem. What are we going to do? We're going to have to pick another quadrant for cosine. So cosine's principal values, when I actually solve for cosine theta in terms of principal values, what I'm asking you to do is to solve between 0 degrees and 180 degrees. That gives us a positive and negative quadrant. It's a little bit confusing because now I have two different versions. Okay. Now the last way I could ask you to solve for it is I could say solve for x and give you no instructions at all, in which case you could actually do this angle theta, or you could end up doing radians. Don't worry about that so much. That'll become clear in a moment. Okay. So let's say I really want to do this. Okay. So I'm going to go ahead and let's see here. So I need another space. So here's what I'm going to do. I'm going to pause for a moment. Pause. All right. So I'm going to give you a new example problem. So the new example problem would be solve for principal values of theta given, let's do cotangent theta sine theta equals √2 over 2. All right, so I start with this problem. I got to do good algebra. I got nothing to do. Then I start going, oh, well, I can actually change these to sine and cosine. So I'm going to go ahead and do that. I'm going to do cosine of theta over sine theta times sine of theta equals √2 over 2. The sine thetas cancel out, and I get cosine theta equals √2 over 2. Now I'm solving for principal values. So I go, I need all the answers that are between 0 degrees and 180 degrees. And I know, since there's only one answer here, I'm only going to need to find one solution. Cosine is positive, so positive in the first quadrant. √2 over 2 is 45 degrees. So my answer would be theta equals 45 degrees. If I gave you instead the exact same problem, but I put a minus sign here, then it would have been exact same work. I would have gotten to cosine theta over sine theta, cross cross, equals negative root 2 over 2. I would then get cosine theta equals negative root 2 over 2. And then I go, where is cosine equal to negative root 2 over 2? And so then I'd realize I had to be in the second quadrant. My reference angle is 45 degrees. So this has got to be 135 degrees. So my answer would be 135 degrees, right? And so that would be the answer for that. Fair enough? All right. So that's your introduction. Try the problems 1, 3, 5, 7, and 9. If you are in period 5, that's your homework. Get that done in addition to finishing 410. If you are in period 7, you're going to have to get the practice 1, 3, 5, 7, and 9. When you get that done with 1, you're going to have to come back, watch the video on problem 1, make sure you did it correctly, then do 3, same routine, 7 and 9. Okay, thanks all. Send your questions through Teams or through email to me. Thank you. Bye.